All right, so as what you can see on this screen, so it shows the learning outcomes in Module 4, and it talks about the decision-making structures. First, we need to understand the decision-making structures, and we have to create the syntactically and semantically correct computer programs employing the decision-making structures, and in which at the end of um, this module is a brainstorm on how to create programs applying the correct syntax and semantics, employing the decision-making structures like if, else if, the nested if, the multi-way selection structures like using the switch. All right. So, this one, it involves different topics for the making decision structures. And we have the following objectives in this presentation. And all of these are under the decision-making structures. Now, first, programmers will have to plan the logic on running the program or the flow of the program. And for that, before creating the program using the applicable the specific language, the plans are made using the pseudocode and flowchart. So remember, pseudocode of the program, like using the pen and paper, okay, writing the flow of the program in an English-like statements. And also, you can use the flowchart. It's just using the symbols in a flowchart for showing the flow of the program. Okay. And it uses the variety of shapes for the different tasks. Like for the basic input and output, we have the parallelogram, the rectangle, for square for the process. And for connecting the flow, we have the arrow. And of course, the terminal, which shows the start and end of the program. Remember, last modules, we used programs in a sequence structure in which one step follows another unconditionally, meaning, meaning there are no options, there are no decisions that happened in a program, meaning all of these steps are being executed sequentially. And this figure shows a flowchart of a series of sequential steps. So all of the steps starting from step 1 up to the last step are being executed sequentially since this program is using the sequential structure. Now, for planning decision making logic, we have to consider the decisions, which involves executing among the alternative steps, but of course, based on some value within the program. And that value includes the decisions which evaluates either true or false. Just like this figure, which shows a flowchart which includes a decision. The first two steps here are being executed one after the other. And after the second step, that is after turning left on Russell Road, we have a decision logic here that evaluates either yes or no, or true or false. The question is the expressway backed up? If it is yes, these are the steps to follow. If no, the other alternative steps are being followed. After that, the last step is being done. So, in decision making logic, there are some alternatives that will not be executed. Okay? Which depends on the value in this decision making logic. Now, in decision making structures, we have to use an if statement. So, this is the simplest statement to make a decision in which it contains a Boolean expression within a parenthesis. In a Boolean expression, you may use the equal sign for determining the equivalency. Remember, equal sign, not the assignment operator. So there must be two equal sign here. If it is only one equal sign, then it is not a to determine the equivalency. It's an assignment. Just like this figure. The if statement is being used as a decision making logic where the Boolean expression quiz score is equal to 10. If quiz score is equal to 10, this statement is being executed. Meaning, if this Boolean expression evaluates to true, the statement the score is perfect will be printed. Otherwise, there's no statement being printed on screen since this is a one-way decision logic. One-way decision logic meaning there's no other alternatives if the Boolean expression evaluates to false. Okay, and it is shown in this flowchart. Okay, and we have a diamond figure for our Boolean expression. Is quiz score equal to 10? And if it is true, it will display the output score is perfect. If the Boolean expression is false, it will end the logic. Okay? Now, there are some false on using the if statement, like misplacing a semicolon in an if statement. Just like this one, it's considered an empty statement, empty if statement, meaning the decision logic is being ended here. As a result, this statement of displaying the the score is perfect will be printed no matter what the Boolean expression value, no matter what's the value of the Boolean expression, whether it's true or false. Since the if statement is being ended here and it's considered as an empty statement. even if you are implementing an indentation here. So don't put a semicolon after the if statement. Another one is uh, mistakenly putting an equal sign instead of double equal sign. Okay? And use the standard relational operators to compare the values of primitive types like less than or equal to, greater than or equal to. And you can also use the equality operator, the equal to, and the not equal to. And also, you can use the reference types as your as part of the Boolean expression. Now, we have different alternatives for the decision-making logic or decision-making structure. We have single alternative if. For the single alternative if, like it's based on one alternative, meaning there are no statements under um, the condition if the statement is false. So there is no other statements to be executed if the condition is false. The dual alternative, there are two possible courses of action. Okay? Like using the if else statement for the dual alternative. So it performs one action when the Boolean expression evaluates as true and another different action when a Boolean expression evaluates as false. So there are two possible courses of actions. Now, for the if else statement, a statement that executes when if it is true or false and ends with a semicolon. And you must have to vertically align the keyword if with the keyword else. Remember, it is illegal if you will have the else without the if. If you have the else statement, it must be paired with an if statement. Just like this one. So there are two possible courses of actions depending on the value of the Boolean expression. If the Boolean expression is true, the statement, the score is perfect, will be printed. Else, meaning if quiz score is not equal to 10, whether less than or greater than 10, the statement, no, it's not. Now, using the multiple statements in if and if else clauses. So, if you have the multiple statements under if and if else clauses, you must have to use the pair of curly braces. This example is not using the multiple statements under if and else, meaning there is only one statement under the if statement. So the curly braces is not needed. Okay? And there's only one statement also under the else statement. So you don't need to put the curly braces. But if two or more statements that will be executed if the Boolean expression is true, therefore the curly braces will be needed. you forgotten to apply the pair of curly braces for a multiple statements under the if statements, it will be treated like this, that only this expression is treated and evaluated if the condition is true. And overtime pay is equal to hours minus full week times UT rate times rate. And this statement will be considered as not part of the if statement. Okay? So it's not part of the decision-making logic here. So for that to be included, this statement in this if statement, you must have a pair of curly braces. Okay? Now you can nest the if and if else statements. Okay, nesting, like if within the if, you have other decision-making logic inside the if statement. Okay, for this one, the two conditions must be met before some action is taken. Okay, just like this one. Okay, just consider this figure. We have the condition items sold is greater than or equal to min items is true. If this Boolean expression is true, there is another Boolean expression. Okay? Is total value greater than or equal to mean value? Then bonus is equal to sales bonus. Okay? In this case, the two Boolean expressions must be evaluated to true to execute this statement. Alright? If ever on the first statement, the Boolean expression is false, it will be ended. Now, you can use the logical and the logical or operators as part of your logical expression. Okay? The logical and operator is an alternative to some nested if statements. And you can use this one, the two ampersands, for your logical and operator. Just like this one. Since there are two Boolean expressions to be executed, this bonus is equal to sales bonus, then you can combine this nested if statement to use a logical and operators. That is to convert this one into a single if expression using the logical and. It will be look like this, that item sold is item sold greater than or equal to mean items, and total value is greater than or equal to mean value, then bonus is equal to sales bonus. Since these two Boolean expression must be true, therefore you can combine it into one statement. Okay? And it is shown in this figure. Okay, instead of using the two nested if or the nested if statement, it can be combined to this one. Okay, like getting the two Boolean expression and applying the logical and operator. That's the same effect. Now, using the logical or operator, so you can use the two pipes. Okay, that the condition is true if either of the expression is true. Remember the or operator. So either of the expressions is true. The alternative will be executed. Okay, just like this one. Okay, using the logical or operator of this if else statement where there is an if under the else statement. Meaning, if the first Boolean expression is false, there is another condition to be executed if items value is greater than or equal to mean value, then discount rate is equal to discount. Meaning either of these two statements will be true, discount rate is equal to discount. For that, you can use the logical or. Okay, if either this condition is true or this condition is true, the discount rate is equal to discount. Now, you can use the short circuit evaluation, which includes expressions on each side of the logical operator are evaluated only as far as necessary. And this will be used to determine whether an expression is true or false. Okay, so you have to check to make sure that your decision is correct, that your decision logic is correct. And let's avoid asking multiple questions. That is why before implementing the program in a specific language, the best decision of a programmer is to use the pseudocode and our flowchart. Okay, just to make sure that the program has implemented the correct logic, including the decision-making logic and the repetition structure logic and other logic that is needed in the program. Okay? We have here a sample program which repeatedly asks the question. Okay? We have here the first condition is if sale amount is greater than high lim, then commission rate is equal to high rate. The second if statement is asking if the sale amount is greater than or equal to mid lim. Okay? Commission rate is equal to mid rate. So for this one, please avoid of doing so that a high sale amount will result in a medium rate commission. Okay? And it is efficient to ask a question most likely to be true first. Okay, this will make a sequence of decisions to be more efficient. Okay, just like this one. Okay, just to convert the multiple if statements to here. Okay, so that just putting the statement which evaluates to true at first. That if sale amount is less than low limit, commission rate is equal to low rate. Else, inside the else statement, we have the if else statement, meaning if the first Boolean expression is false, it will go here and evaluate the if else statement. That if sale amount is less than mid lim, commission rate is equal to mid rate. Otherwise, commission rate is equal to high rate. Okay, so that's the matter of evaluating and deciding which statement will be evaluated as true first. That will be put as the first if statement Boolean expression. And of course, applying the logical and the logical or operators appropriately. Okay, when will you apply the and? If both of the Boolean expressions are true, so you have to use and. Okay, if either of the two expressions is true, you have to use the logical or. Now, the multiple decision making logic involves the switch statement. Okay, so for the switch statement, an alternative to a series of nested if statements. So, switch statement will be used where the testing is made using a single variable against a series of exact integer characters or string values. So you can use the integer character or string values for each of the cases. And these are the keywords to be used using the switch statement. Switch keyword to start the structure of the switch. Okay, it will be followed by a test expression which is enclosed in a parenthesis. And the case keyword will be used to use possible values for the test expression and a colon. You may use the integer, character, or string. The break statement will be used to end the statement in each case. And the default keyword is an optional that is used prior to any action that should occur if the test variable does not match any of the cases. Just like this one, using the switch statement of evaluating the year's value. Okay, take note after the expression of a switch statement, we have a pair of curly braces to enclose the cases and the default, okay, in which default is optional here. If the year's value is 1, freshman will be displayed. On the other hand, if the year's value is 3, junior will be displayed. What if the year's value is 5? What will be displayed? It will display an invalid year. Correct. Since the value is not found in any of the cases. Now, there are times that you are going to omit the break statement. Okay, if ever the following statements under the following case will be executed, so you can remove the break statement. Now, why do we need to use the switch statement? They are convenient when several alternative courses of action depends on a single integer, character, or string value. And this is used only when there is a reasonable number of specific matching values to be tested. Like all the values belongs to the case. And if ever the values doesn't belong to any of the cases, then it will proceed to the default statement. Now, you can use the ternary expression as part of the decision making logic. Okay? And the syntax of using the ternary operator is like this: the test expression followed by a question mark, true result, colon, false result. How will you interpret this one? If the test expression is true, the statement under true result will be executed. Otherwise, this statement here will be executed. And this is the shorthand expression for using the if-else structure. But it is optional. It's up to you on how will you use, whether you're going to use the ternary expression or the conditional operator. Okay? So using the conditional and not operators, the Boolean expression is evaluated as true or false, of course. That if the value of test expression is true, the entire conditional expression takes on the following or on the value of the expression following the question mark. And if the test expression is false, the entire expression takes on the value of false result. And this is an advantage of using the conditional operator in the conciseness of the statement. And we'll have a demonstration later. Now, using the not operator. So you can use this exclamation mark for the not operator. Like not true. So the opposite of not true is false. Okay, and it requires a double set of parentheses. Okay, applying the not operator to a Boolean expression. Okay, and also you have to remember the level of precedence since we are going to use the different comparative operators and the relational operators, and of course the logical and the logical or operators. Remember, okay, the arithmetic expression is done first, and remember that the assignment statement is being done last. Okay, and also whether given the two logical operators and or, if ever you have to use these two logical operators and has a higher level of precedence than OR operator, meaning the AND operator will be evaluated first for the OR operator. And of course, those statements that are placed inside the parentheses are evaluated first. Okay, like given in this table, the operator precedence for operators used. The logical NOT is or has the high level of precedence. Okay, but of course, those expressions that are placed within the parentheses must be evaluated first, or if is evaluated first. And given the um, arithmetic operators, MDAS will be evaluated first before addition and subtraction. Then, for the relational equality, for the relational and equality, the relational are evaluated first before the equality. Then, for the logical and is evaluated, then or. Okay. Next is the conditional statement. And lastly is the assignment statement. Okay. So we have the two important conventions for the operator precedence. The first one is the order in which operators are used makes a difference. Of course, because the level of precedence is important for making a decision logic. And always use parentheses to change precedence or make your intentions clearer. So you must have to um, correct the logic of your decision making structure when it involves the different operators to be used as part of the Boolean statement or Boolean expression. Okay, just like this one. This statement involves the comparative, the logical and comparative, and the equality. So in this case, this will be evaluated first. This one and this one, since it involves the lower level of precedence. So these Boolean expressions are being evaluated. So whether this evaluates to true or false, the result of these will be evaluated to logical and logical or. But whether given the two results or given the two expressions of um, using the or and, this will be evaluated secondly. And the result of this and expression will be evaluated to or. Okay, so second, then third, which is the last one. The last operator that is being evaluated or being executed is the or logical or operator. Okay? If you want to process the logical or first over logical and, so you must have to put a pair of parentheses. Okay? Just to make it clear that if either of the traffic tickets is greater than 2 or age is less than 25, it's true, will be evaluated to, and gender is equal to N. So extra premium is equal to 200. So the inner expression here is evaluated first before the outer expression. Okay. Now, it can be added, or the decision making logic can be added to statements within the methods of classes and objects, of course. That's, for example, adding decisions and constructors to instance methods, like verifying the pay rate, for example, for each of the employees. So it will help ensure that fields have the acceptable values if ever the values will be passed to the constructors. And it will determine whether values are within the allowed limits for the fields. Like, for example, for the employees, the age, if you are to record the employees' data, okay, and age is needed for storing the data, okay, those employees of greater than or equal to 18 years old is accepted in the company. Okay, something like that. Okay, so just like this one, adding a decision making logic to the constructor, where this constructor will accept the two values. The first one is of an integer and the second one is the double. That the value of num is being evaluated, and if it is less than or equal to max emp number, so emp num is equal to num. So the value of num will be assigned to the instance variable value emp num. Okay, otherwise, emp num is where the value of the variable emp num will receive the value of the maximum emp number, which is 9999. And if pay rate is less than or equal to max rate, so the pay rate instance variable will be set to the value being passed as argument for this constructor. Otherwise, pay rate is equal to 0. Okay? And that's the end of this discussion. And on the next one, we will have the demonstration of using the different decision-making logic structure.